particular, we're going to look at the concept of standard input and output. We'll look at the functions getChar and putChar, and then finally we'll take a look at how to do formatted input and output using printf and scanf. The notion of standard input and output relates to command line programs, and it's a notion of an input and output stream that command line programs can read to and write from, and this is common in all Unix and Unix-like systems such as Linux. Now, the C language doesn't actually have any special syntax for input and output. Instead, what C does is it defines a library of functions that support integration with standard input and output, as well as functions for interacting with input and output with regard to files. So the first function we're going to look at today is the getChar function. getChar is used for reading input from the standard input. And that means if I run a command line argument and I use the getChar function, it will actually read right from the terminal window. In other words, whatever I enter on the keyboard at that time will be fed into the program as standard input. And so getChar reads the next available character from standard input, if there is one available. And if it's reading from the standard input on the terminal on the command line window, it's actually going to block or pause if there is no input. The function returns EOF, and that's all caps, and that's going to be defined in that pound include stdio. So the stdio.h file defines that, and whenever we hit an end of file or an error condition, we're going to get that EOF value back from the function. The analog to getChar is putChar, and putChar is what we use to write to standard output. So if we're on a command line, standard output would actually go to the terminal window itself. putChar takes a character, or it takes an int actually, and putChar writes that character or that int to standard output, but it's going to convert it to an unsigned char. And the return value of putChar is actually the character that was written. Now putChar and getChar are fine, but they're quite simplistic and they don't do a lot for us. C also defines two additional functions that we can use for formatted input and output. So first of all, let's look at formatted output. The printf function is what we use to display formatted output to standard output. And its syntax is shown here. You're going to use the keyword or the function name printf with an open left paren, and then there is a format string, which is going to be a string value, followed by an arbitrary number of arguments. And we'll see how this works in a moment. But the arguments are actually the variables whose values we're going to print out, and the format string tells printf how we want those values to be displayed. So here is a simple example. I have a printf statement. My control string here is who : %s, size : %d, cost : %5.2f. So everything in between the double quotes there. And over to the right, you'll see three variables listed. Those %s, %d, and %5.2f are actually control strings inside my format string. And what this means is that the values on the right are going to be substituted in the format string. They're going to substitute the %s, for example, with the string u, the 12 with the %d, and the 1.2 with the %5.2f. And this works in a positional fashion. So the first % variable in the control string, or the format string, is going to be replaced with the first variable over to the right, and so forth. And we can have a variable number of these. So the s, the %s, means string, the %d means integer, and the %5.2f stands for floating point, 5 digits with 2 to the right of the decimal place. So if we looked at the actual output generated here, we would see the string who colon u, size colon 12, cost 1.20 because we have 2 places to the right of the decimal place. C has added in that 0 for us. We can also do formatted input. So scanf is a function in the standard input-output library that reads formatted input from the standard input. So similar to printf, we're going to have a format string as the first argument, and then we'll have multiple arguments, a variable number of arguments following that format string. And it's very important to note on those 2 arguments we show here, there's an ampersand. This ampersand is actually denoting the fact that the arguments are not the arguments themselves, but the variables themselves, but they're the addresses of those variables that will store the values being read here. So this is very important. You have to put that ampersand in front of the variable names. And when we get to pointers, we'll talk more about the significance of that. But for right now, take this on faith. When you're using scanf, always put the ampersand in front of the argument name. And once again, the format string in this function tells us how the input is to be formatted. So here's a simple example. If I had standard input of the character Y space 101, and I had the scanf statement as shown here, %C and %D, it's actually going to store the Y is going to get mapped to the %C, the 101 is going to get mapped to the %D because it's an integer, and ultimately those values will be copied in to the variables C and I that are defined above. So let's take a look at some actual code. Let's write an example program that uses the standard input and output routines that we just discussed. So I'm going to have a program here called iodemo.c, and the first thing I'm going to do whenever I'm using standard I/O is I'm going to include the standard I/O header, and then I need my main routine. So once again, main will return an int, but I have no arguments for now. And let's write a printf statement. And this time, instead of just a string like we did last time, we'll actually put some control variables in the string. So we'll say my initials are, and then I'll put %C, %C, %C for my 3 initials, and I'll say, and my age is, and then I'll put an integer followed by a period and a new line. And now I need to put those values, so I'll put a capital J, and notice the single ticks, these are character literals. So there's my initials, and then my age, we'll just say it's 28. How's that? Alright, and now I need to return a 0 and close off my block. Okay, so there's my program. I've basically printed out my initials and my age, and it's going to substitute in those literals on the right in the actual % variables there. So if we compile this and run it, it does exactly as we expect. But let's also let's go ahead and read that data now from standard input instead of just printing out literals here. So if we're going to do that, we need some variables to store the data in. So we're going to need 3 car variables. So we'll say F for first initial, M for middle initial, L for last initial, and we need an integer value for the age. Okay, now we have the variables defined. Let's write a scanf statement to read this data in from standard input. So I'm going to put my format string first, so we need 3 characters. So I'll just put in 3 characters, and I need 1 integer. And now I need to put the variables that are going to hold these values. And remember, we have to use the ampersand here to designate the fact that we're sending an address to the variable and not a copy of the variable's value itself. So we put an ampersand F for address of the variable F, address of the variable m, address of the variable l, and address of the variable age. Alright, now if I run this, it's going to basically read these 4 values from standard input and store them in the respective variables. So let's go ahead and save it, and again we'll compile and run it. And notice nothing's happening. It's reading from standard input. That means I can actually type from my terminal window now, and it will read this as standard input. So I'll type a capital J R E, and let's say I'm 32 now. Oh, something happened. It printed 28. Ah, we forgot to change our printf to print from the variables instead of the literals. So let's go back in and do that. So we'll go over here, and this now needs to actually get the variables f, m, l, age. And let's try it once more. Sorry about that. Okay, so we'll compile again, and then we'll run iodemo, and this time we type JRE32, and sure enough, it worked. Let's do one more thing. Let's make our program more user-friendly and have it actually print a prompt out to the end user. So we'll go back into our editor, and let's put a prompt right here. So we can just say something like this: print, enter your initials followed by your age. And notice I'm not putting the line feed here because we want this to print and then wait for the user to enter this information. So if we build this one, and now when we run it, it actually prompts us for this information. So there's a very, very simple example on how to use standard input and output using printf and scanf. Let's take a look at one more example program. You'll recall in the previous video we talked about sizes of, an operator that the C language provides to help us figure out how many bytes each variable will occupy in memory. So I wrote a really simple program here called sizes, and sizes defines 2 variables, an integer I, a double D, and a character C. And what I did was I used a printf statement, and size of returns a size underscore t, which will vary by the machine and compiler we're using. And so a portable way to do this is we're going to typecast. We saw that also in a previous video, but we're going to typecast the return value of size of to unsigned long, and then we'll use %lu to get that value to print in a format string of printf. So here what I've done is I've passed I, D, and C to the size of operator here, and this basically will tell me on this particular machine how many bytes each of those variables occupies. So let's go ahead and compile this, and if I run it, we can see now that an integer takes 4 bytes on this machine, a double takes 8, and a character takes 1. So there's a very simple example showing you how to typecast as well as the size of operator.